Hi Calculus student, this video is for chapter 5.1, Approximating Area. In chapter 2, we mentioned that the second problem that calculus tackle is being able to approximate or being able to evaluate actually area under the curve that is not of any particular shape, like not a circle or rectangle or triangles. So given any curve, any function, we can find the exact area under the curve. In chapter 2, we talk about, we can cut it into like big triangles. Actually, the width is 1 or half, and then add them together. The approximation is not very good if the rectangles are too big. So in here, we would talk about how to cut it smaller to get a better estimation. Because we're adding a lot of rectangles together and they have some kind of like sequence. So we are going to use segment notation. So the first part of 5.1 is to review segment notation and see how we can use some of the sigma formula for sum and power of integers to actually eventually calculate these area approximation. So what is a sigma notation? A sigma notation is a short form to represent sum in a compact form. If I want to write 1 plus 2 plus 3 up to a number n, I don't know what n is, but every time I add one number, so I can write it as sigma I equal to 1 to n. So when I type it in Word, it's the I and n are like behind sigma. But actually, when I write it, it should be like that. It should be sigma, and it should be below it. I equal to 1 to n. So the number at the below is the starting number, and then you talk about what you are plugging in. So I means every time I'll just plug in 1, and then 2, and then 3 up to the ending point. So this is called the index of the summation. You can use I, you can use J, you can use K. And in the graphing calculator, they actually use X. So long as these two match, it's kind of like the input. So input one at a time, and then every time you increase by 1. Okay, so it could be just any pattern. So you can say AI, which is a term of a series, a term of a sequence or series, I don't know. So you can say I equal to 1 to n, then it would mean a plus a sub 1 plus a sub 2 all the way to an. So you can think of I as a substitution, like an input substitution, where the domain is just the natural number from 1 to whatever. Now, but technically, very often we start from 1 and then to a number, but technically you can for the sigma notation you can start from anything. So like look at this one, I can start from 0 and stop at 4. I can even start from 6 and then stop at 10. So it could be any number. So let's try to use it and figure out what this means. So A is find the sum by expanding. So you know what they want. They want I minus I squared in every single term, and I is from 1 to 6. So I can think about this as 1 minus 1 square, plug in 1, plus 2 minus 2 square, plus 3 minus 3 square, all the way up to what? Like 4 minus 4 square, plus 5 minus 5 square, plus 6 is the last one, 6 minus 6 square. And if I add all of these together, I add them before, it was negative 70. Right, negative 70. So you put in the calculator, it is negative 70. So you can, this is what you're calculating every time you plug in the I. The second one is I'm going to use the index k, and I want to start from 0, like what I said before. And then the substitution that you want to add, every single term is 4 to the k. So this k doesn't have to be in a particular place like the integers that you're adding. It could be the exponent. It could be the denominator of a fraction or anything. So so the first one you would be adding would be, you plug in k equal to 0. So it would be 4 to the 0 plus 4 to the 1 plus 4 to the 2 plus 4 to the 3 plus 4 to the 4 because you stop at 4. So if you add all this together, I did it. So in my calculator is 341. You just add them one by one and then you get the number. So that's the idea of the sigma notations. Now, people figure out that if you add I together, like if you add 1 and 2 and 3, all the way to I, there's a way you can add this. And actually, if it is stopping at n, the formula that you can replace this instead of putting the calculator one by one, which is fine. But if n is like 100, it takes a long time. So they have a formula for it that which is sigma I equal to 1n. I would be n plus 1 over 2. So this is the n that you stop at. It turns out that it's related to what you have stopped at. Okay, is the last number that you stop times n plus 1 over 2. There is a story that this was it was known by Euler when he was very young without studying any math, and then I square would be n plus 1 to n plus 1 over 6 sigma I cube, meaning if I add 1 cube plus 2 cube plus 3 cube plus 4 cube up to whatever that I want to, n cube. I don't have to do them one by one in my calculator. I can just use the last numbers, put it as a formula, and I will get the answer. So these are called summation formula for sum and power of integers. So these three are frequently used in calculus class. So let's try to use them. Let's try to understand. Okay. So A, I want to add I from 1 to 20. So last time when we were expanding by hand, we just go to 6 because it takes a long time to enter these numbers into the calculator. But I from 1 to 20 is quite a big number, so it makes sense to use this sum of power of integers. So the first thing we want to circle is this is n. N is 20. And then let's look at these that have I have I squared, so this corresponds to this 2 formula, but they have coefficients next to them. So I'm going to split it up into one by one. So this is I equal to 1 to 20, 4 minus 2 times, the 2 can be moved out, I equal to 1 to 20 again, I, it's kind of like distribute property, plus I equal to 1 to 20 I square. So you can see that this is exactly this, I can exactly apply this formula. Now there's nothing for it. That means what? That means 4 times 20. Every time I'm just adding 4. I add 20 times. Just mean that's just 4 times 20. So it's 80. Plus, what do I do here? I have to write the formula, right? Maybe I'm gonna, there's not enough space here, so I'm gonna erase this and do it over here. So I would say that's equal to 80 minus 2 times of my, I'm gonna plug in formula, n is 20, which is sigma I. So this is sigma I. 20 times 21 over 2. 2 times 21 and 21, so these two cancel. Okay. Add sigma I square here. N is 20. So be 20 times 21 times 2 times 20 is 40, 41 over 6. And if you add these together, did I do that? 25, 30. So you see how this is much faster than actually doing 20 number here, well, 20 number here and 20 number here. So that's this formula help us. And the I is over here. Okay, so we can do this also. But now look how this is very big, but you can write the formula. Let's write it out. Now, there is no I minus 3 square here. So the way to do it is you would expand them. I equal to 1 to 200. N is 200, you can tell. But then I FOIL it out. So I square minus 6i plus 9, right? And then I do them one by one, just like before. sigma I square, I would use this, but my n is 200, so it will be 201 times 2 times 200 is 400, 401 over 6. That's the first one, I square, minus 6 times I is this one, right? 200 again, and 201 over 2 plus 9 times 200, right? So if you put in the calculator, you'll get a number. But this can be done by the calculator also. So I'm going to show you how to do it with the with decimal as well as the graphing calculator, because these are really big numbers. And let me write down. Let me write down. It's I minus 3 square. I minus 3 square from 1 to 200. So I will go to decimal. Okay, so decimal has a function, and at the bottom there's a sigma notation from 1. So all those formula must start from 1, 200. What do we have? What? I minus 3, right? Oh, this index they use n. I'm going to change it to I. I minus 3 square. Ah, you get the number right away. It's 2567900. And then in the calculator, you can do the same thing. Okay, math. Go all the way down. Oh, this is 84. If you have 83, you can call up summation using catalog and kind of do it. But you have to ask me. It's much longer. So you would say you cannot choose I or n. It has to be x. X equal to 1. Go up to 200, right? And then you would say inside is, right. I think you would have to say parenthesis, what, I minus 3? X minus 3. X minus 3, close parenthesis, and then square. And you will notice that you get the same answer, 2567900. Right. So you can do it with the calculator, but without using the formula. But you can also do it with the calculator. So let me write down the answer. So either way, you can use the calculator, you can use a scientific calculator, you can use a graphing calculator, you can use decimal, 2567900. Okay, so you can see that it is very powerful for adding numbers together. So we don't have to. So there's 2 more that I want to do. So maybe I'll do 1 more because I have 2 minutes left. So I have this is a little difference. My inside is not a number, but it's f of I. But f of x is x cubed. So basically, it is I equal to 110 I to the power 3, right? I to the power 3 had a formula, which was what? We never use I3. N squared, n plus 1 squared over 4. So my n is 10, right? 10. So 10 square, 10 plus 1 square, 11 square over 4, right? So you can do it with the calculator, 3025. And we can do this also. Now n is n, so we just use it, right? So maybe I'll do it over here. So I would write 1 over n squared is not related to the indexing, so I can move it out. And then this would be equal to sigma I equal to 1 to n, I plus 1, right? So 1 over n squared, I was what? Sigma I is n plus 1 over 2. It's just by coincidence that you have the same n plus 1. 1 is n, right? So then you can distribute it and simplify. So this is the summation in terms of n. So when you do adding those rectangles together, these are useful.